applying what we just saw, that the absolute value, or that the distance between 2 points on the real line is the absolute value of their difference, and it doesn't matter in which order you do that difference as long as you subtract. We see that the distance between x and -5 is x minus absolute value of x minus -5, which of course is the absolute value of x plus 5. And the distance between x and h is the absolute value of x minus h. The distance between x and 4, the statement that the distance between x and 4 is less than 7 is absolute value of x minus 4 less than 7. The statement that the distance between x and -5 is greater than 2 is absolute value of x minus -5 greater than 2. And of course that could be written as the absolute value of x plus 5 is greater than 2. The absolute value of x minus h less than a indicates that the distance between x and h is less than a. Now we can picture each of these situations. Okay, first of all, the distance between x and -5. Okay, if we do x minus -5, that's going to give us an expression whose absolute value is the distance between x and -5. Now, if x happens to be to the right, we don't even need the absolute value signs. The distance from -5 to x is x minus -5, or x plus 5. It's x plus 5, of course, because 0 lies in here someplace, and this distance would be x, and this distance would be 5, and we would have distance x plus 5. If x happens to be to the left of -5, this still applies. Although if we just wanted to do the subtraction without the absolute value signs, it would be -5 minus x. Okay, -5 minus x is going to give the distance between x and -5, provided x is to the left. That is, x is less than -5. Either way, the absolute value of x minus -5 gives us the result. So whether x is to the right or left, this absolute value will give us the result. Okay, now the distance between x and h is the absolute value of x minus h. Right there it is. Now the statement that the absolute value of x minus 4 is less than 7, what does that say? Well, now, here I've indicated all the x's for which this is true. Here's 4. Okay, if x is here, then x minus 4 is this distance. If x is over here, then the absolute value of x minus 4 is this distance. Okay, if the distance between x and 4 is less than 7, then the inequality holds, otherwise it doesn't. So where does the distance between x and 4 reach 7? When x is out here 7 units to the right of 4, or out here 7 units to the left of 4. So the set of x values for which absolute value of x minus 4 is less than 7 extends 7 units to the right of the x equals 4 point and 7 units to the left. Any point between here and here is within 4 units or 7 units of 4, and the absolute value of x minus 4 then is less than 7. Very important thing to understand for applications and just solving the problems that you're going to have to solve. Okay, now again, we do the same for absolute value of x minus -5 greater than 2. This is a set of x values that lie at least that lie greater than 2 units from -5. I mean, here is -5. Okay, if x is here, then the absolute value of x minus -5 is bigger than this distance 2. If x is over here someplace, its distance from -5 is again greater than this distance, which is 2. And I guess I should probably put a 2 on this. So think about it. You need to understand why this inequality, x absolute value of x minus negative 5 greater than 2 is interpreted as the set of all x values that lie more than 2 units from negative 5. And here, absolute value of x minus h less than a is depicted this way. Here's x equals the x point where x equals h. Here's the distance a on the right. Here's the distance a to the left. And x has to lie between here and here.